Here are the answers explained for Geometry Test 1, Form A. So the first question, if P is true and not Q is true, which means Q is false, P and Q would be true and false, but and is only true if both are true, and that's why that one's false. Now, Q implies P, so Q is false, and P is true, and false implies true is true. The only one that would be false, if it was true implies false, that's false, but all other combinations of true and false are true. Not P or Q, that's true if either of them are Q. Well, not P is false, but Q is false also, so they're both false, so that one's false. And in this one, I changed it, but this is the one that you had, I think. So P is Q, P is false, P is true, and Q is false, so not Q is true. So P and not Q, that's true. And P and Q, since Q is false, that's false, and then true and false, they're not both true, so it is false. Number 5. If the original is P implies Q, or in this case, P implies not Q, if you do not eat an apple a day, that's not P. And then you will need to go to the doctor, that's regular Q. That's the inverse. The inverse is the one where the order stays the same, but the two things are negated. In the actual question, the order of these choices might have been changed around, but the answer was inverse, whatever letter that ends up being. Oh, I think number 6, I think that question was just removed from your test. I think there ended up being only... Now I got to think about what was there. Hold on a second. Oh, there was a question 6. That wasn't it. I don't have that question 6 handy as I'm making this video. Over here, notice how this is true when these things are different from each other, but it's false when they are the same as each other. And that's why the answer is choice D. P with biconditional with not Q. So not Q, which is not one of the columns, but it would be false, true, false, true. And then when are those the same? They're the same here, and they're the same here. That's why false, true, true, false could be described this way. Now these questions might be in a different order on the test that you took, but for this one, P or not Q, and not Q is given as true. So, well, if this were the actual question, which I'm not sure if, I'm using this rough draft as the scan, because that's the only one I have accessible right now. If the question was like this, it would be not valid, because or means one of them has to be true, at least, and then not Q, that's one of them being true, so P could be either true or false. This one over here, this is definitely detachment, because you have P implies not Q, and then you have the thing on the left, so the thing on the right, exactly as it is, would be the conclusion. And for this one, this is a modus tollens situation, because this is the opposite of the thing on the right, which makes the conclusion the opposite of the thing on the left. And this one, if this is what it was, is not valid, because that's not how De Morgan's rule works. You'd have to flip the sign there. And for this one, false implies true. That's actually true. The only untrue conditional is true implies false. So even though this is false, this is kind of like that Pope example that I did in class. Now over here, if your chickens haven't hatched yet, then don't count your chickens. That's the original statement. That's equivalent to the contrapositive, where you swap the order and you negate the two things. Well, they're already negated, so they become regular. That's why the answer is, if you count the chickens, then they have hatched. That's the contrapositive, which is logically equivalent to the original. Okay, so let's look at this truth table. When it's an implication, it's only false if there's a true implying a false. So I look here at the P column and the not Q column, and there the top one is true implies false. The next one is true implies true, false implies false. So that's what the truth table looks like for that one. Now for the not P or Q, I look at these two columns and try to find, is there any, oh, that's and. So I try to find the one where they're both true, which is here, and all the other ones are going to be false. And this last column is kind of similar to this one in that we're looking for a true and a false like that, but all other situations are true. I'm pretty sure this is what was on your test, but if it wasn't, then this question won't apply to that. Now for this one, I changed the question actually. So the question was this: not P and Q implies Q. So there is already a Q column, but it's good to have a not P column and a not P and Q. So the not P column is just the opposite of the P column. And then the not P and Q, I look at these two, and I look for when they're both true. I put a T there, but any other situation, I put a false there. And then the conditional here, again, I look for the thing on the left being true and the thing on the right being false. No, that didn't happen here, it didn't happen here, it didn't happen here. It did happen there. I feel like something's wrong, because this was supposed to be a tautology, I think, but something might have gone wrong here. Again, sorry if I'm using the wrong version of this test for this key. I'll probably make a better version another time. But for right now, let's take a look at question 15. Not P can get combined with this. This is a good detachment example or situation, because you have the thing on the left, not P, which is true, so the thing on the right is going to be true also. Now this Q is also in this guy, so Q is true, so not Q is false, which means R has to be true. That's what disjunctive inference is. Now that R is true, you come over here, that R is the opposite of the thing on the right, so the conclusion is the opposite of the thing on the left. The opposite of not S is regular S. That's modus tollens. Now for number 15, this one doesn't have any single letters, so we're going to need them. We have two De Morgans. When there's a negation outside of a parenthesis, I'm going to take this one. It becomes P, flip the sign, not T. Not given. That's De Morgan. Might as well do this one also. Not P or Q. You negate both things and flip the sign. De Morgans. Now, the most useful one is this top one because it has the and in it, which means I could either say P or not T or both. I'm going to say P, because there's no other T's in the whole thing. So I'll use P by simplification. Now that I have the P, I can combine it with this one. No, I'm sorry, I can combine it with this one. P is true, not P is false. Either not P or Q is true. So since not P is false, Q has to be true. That's disjunctive inference. Now that I have the Q, I can come over here. This is a detachment situation. And now that I have the not are, I see it on the right side, the opposite of it on the right-hand side. So the conclusion is the opposite of the thing on the left. Mortis tollens. Again, there's something, I'm not sure about this. Maybe I changed the question. Something went wrong. I'm not sure. Maybe I even have a mistake. Let me check. Ah, yes, there was a mistake here, now that I've re-looked at it. So we have the P and Q, which is this row column, and the arrows going to the Q, which is this. So I'm looking if there's a true here, but a false here. False to true is true. False to false is true. True to true is true. And false to false is true. So they are all true, and that's why we call that a tautology. Okay, that's good. That's the end of this video.